Hey everybody, it's the Herminator here. We're going to be looking at some more story. Now, this is going to get, I actually hope people get bored with this by Tuesday, because that means you're ready for your test, okay? That's good. Bored means I know it, I'm ready to go. So, that's a compliment. To get your car repaired, you had to pay $76 for the part, $32 per hour for labor. The bill was $124. How many hours did the repair take? Pretty relatively simple problem to start off. So hours is a unit, and dollars is a unit, and that's the only two important units. There's two units. So when there's two units, I assign X to one unit, that's hours, Y to the other unit, that's money. Okay? So you put the Y on top, that on bottom. Dollars per hour is 32. $32 per hour is your rate of change. Easy enough. Now, let's see what kind of a line we have. Anytime we two units after that, you need to see what type of line, you know. A lot of questions to be answered, man. The M gets replaced by 32, because 32X in this problem means $32 per hour. Now, my X starts at 0, and prior to the $32, you paid $76, so with 0 hours, you paid 76. So, not a DV problem, okay? So we got 76, we got 32X, and we have Y. So 76 plus 32X equals Y. Okay, I'm solving for the hours. You got to leave the X. You need to put that $124 in for Y because that's money. You got to pay attention to where you put it in. 76 plus 32X equals 124. Minus 76. Minus 76, so we have 32 times X, and over here we have 48. Okay, divide by 32, divide by 32. So over here you got X, 1.5. 1.5 is okay, it's an hour and a half. Number 2. You paint 2 square yards of a community mural in 3 hours, and a friend's going to paint 4 square yards in 5 hours. How long, that means how many hours in this problem, does it take the two of you to paint 11 square yards and working together? So how long means hours. Okay, so let's see how many units we have. We got hours, and I got square yards. Okay, how many units? Significant units depends on how I'm going to solve the problem. This one has 2 units again, just like last problem, so it's X. You're not going to do it. It's not just like but for now it is. Y per square yards per hour. Now here's what I don't want to see. You don't know the square yards per hour, that's obvious, but I don't want to see you trying to do the Y minus Y, X minus X. On this problem, it'll be screwed up. Before you do that, well, you're like, well, when do I do the Y minus Y, X minus X? It depends if you have direct variation. Be going XY, MXY. We don't have an M, that's obvious. Now remember what the 0 actually means. X is hours, so that means 0 hours, HRS. 0 hours, do you think I'm going to have any square yards done? No, I'm doing work here. If I don't work for any time, I can't get anything done. So that is a DV problem, so I don't need that. That's why I don't want you doing that, okay? Until you recognize it. If it wasn't a DV, then I'd have to go do the Y minus Y, X minus X. But you know, it wasn't, okay? So, I'm going to use proportions here. That's what 2 equal ratios are. You need to put your time unit in the denominator. Always X unit in the denominator and your Y unit on top. Okay, so I have one person that can do 2 square yards in 3 hours. And he gets some help, 4 and 5. And 11 square yards, and I want to find out how many hours. It's important you get your units right. So I know I have 11 over X here, but this is going to change because I'm going to add those together. whoops. I'm going to take 2/3 plus 4/5. 1 7/15. There's two things you can do with that. You can make it an improper fraction, which would be 22/15, and put that in. Or you can put 1 7/15 in the numerator, the whole thing in the numerator with a 1 in the denominator. Either way works because your calculator will get the job done either way. You could also have a big 22 here and a 15 here. Either way is good. So I take 1 times 11, that's 11, and I divide 11 by 1 7/15. See what we get there. Seven and a half, okay? So 7.5 hours. Number 3. A full pool is drained at a constant rate each minute. After 4 hours of draining, it has 1,300 gallons of water. After 10 hours, it has 1,000 gallons of water. How many hours will it take a full pool to drain to 0 gallons? So hours equals okay, so hours in gallons. X and Y. So per gallons per hour. Okay. Now I don't have a gallons per hour. Will I need to find it depending on if we have direct variation or not? Okay, so hours start at 0. But the gallons don't, because as you can see, the gallons are going down in this problem, clearly. Okay, clearly they're going down. So I do not know what goes there. It is not direct variation. We need to use the y equals m times x plus b to find it. So that means we need to get that. So I come back over here. Y minus y, x minus x. So the gallons, we're going to take 1,300 minus 1,000. Meanwhile, we're going to have 4 minus 10, so it's going to be 300 over negative 6, and that's negative 50. Okay. So I know I have negative 50 right here. So we cross those out. So m is negative 50. Now for the x and the y, we need to find a combination of hours and gallons. We can go with these two or these two. We'll go with those two. So 1,000 and 10. Y is gallons, so it's 1,000 gallons. And over here, negative 50 gets multiplied by the 10, because x is 10. So over here, I have 1,000. And negative 50 times 10 is negative 500. And then we have plus b. Do not divide, because that's a coefficient of 1. You don't divide if the coefficient's 1. You add this. So 1,000 plus 500 is 1,500 equals b. Okay, now I have an equation I need to write. I have 1,500 plus negative 50x equals y, and I'm solving for the hours, so I'm solving for that. And I'm going to put 0 gallons in for my y. So 1,500 plus negative 50x equals 0. Get the 1,500 out. Negative 50x equals negative 1,500, and then I divide by negative 50, and x equals 30. Okay, so 30 hours. By the way, that problem I've like repeated that problem. It happens again, there'll be a punishment for me. Okay, first off, we need to add something here, and that's the fact that the cars travel for equal times. Car traveling 70 miles per hour travels 75 miles further than a car that travels 60 miles per hour, and they travel for equal times. Find the distance each car travels. Okay, so distance is measured in mileage, miles. Okay, so my units are miles and hours, and that's it. So again, that's 2 units. So I need to come here and here. X is hours, Y is miles per. Here, this is for my graphic organizer, this is for my equation. Miles per hour. Now I know the miles per hour. I know we got a 70 miles per hour and a 60. So 70, 60, those two things. Those are 2 different units. So X comma Y, MX, Y. X comma Y, MX, Y. So the M's, I got a 70 and I've got a 60. Now the hours begin at 0, but look, when you're driving something, if you don't have any hours, you ain't going to have any miles. Both of them are zeros, so that's a DV problem. So ratios is what I go with. Now, the next thing I'll tell you when to keep writing, okay? What a lot of people do is they'll put miles, hours here. Let me give another thing. They will try this. Miles, hour, because you know it's always the X on bottom. But there's no way that's going to work, okay? I do not have enough information to fill it out when it's set like that. What I do have enough information is to use the fact that the cars travel for equal times. So the times are equal, and that means our distance divided by speed have to be equal. So my speeds are 70 and 60. Okay, and then we know that this faster car, we don't know its distance, but we know it's 75 further, so plus 75. Okay? So, again, you can't multiply and divide, so what I do is I pair them up diagonally. I take 70 times d, that's 70d. And on the other side, I got to take the 60 times d and the 60 times 75. 60d. And 60 times 75 is 4,500. Minus 60d minus 60d. So that is 10d equals 4,500. Divide by 10, d equals 450. So 450 miles is my first answer, and then for my second answer we tack on the 75. So I'm going to put add 75. 450 add 75 is 525. Okay, next problem. You're buying apples and oranges at the store. You have $9.78 to spend. You need 4 pounds of apples and 3 pounds of oranges. The oranges cost 25 cents more than the apples. How much does a single pound of apples, single pound of oranges cost? So, cost of apples, cost of oranges, those two things. So I've got apples, and those are sold by the pounds. It helps if you kind of put what it's sold in, like they're sold by the pounds, but that's up to you. It's not going to probably make or break you. And then money. Oh, 3 units. It's the dreaded chart. Mr. Rower loves this chart, man. Just giving you crap, dude. We good? Yeah. Okay. All right. So we got the totals in the corners. Then, how many? And single, and again, that's a lot of people. If you haven't had me for algebra before, this chart's going to be kind of weird at the beginning, but you'll get used to it, okay? Just got to keep working on it. Okay, so we put the apples and the oranges, and then my money is single and total. Okay, how much does a single pound of apples cost? We want to talk about these 4 things first. There's no cost. I mean, here's a cost, but that's not for a single pound of apples. And the more than that don't mean nothing for now. It will in a second, but not now. Put question marks before you put variables. How many units of apples do we have? I think we have 4 of those. And this is for non-money, this stuff. It's for the units themselves. And this is 3. Okay. And then the total is $9.78. Okay. Okay, now there's this 25 cents more. Okay, and that's money, so we don't no business up here. Okay, it's a money amount. It's going to go here. Now that's 25 cents more, so we put plus 0.25 in for the apples. Or no, I'm an idiot. The oranges cost 25 cents more. Yeah, if I'd have done that, it would have been screwed. Now, there's no need to use, at this point when I'm able to put that plus, I'm only using x. Okay. So x and x. So I multiply 4 by x, 4x, and then I distribute the 3 to both of these. You got to remember, you can't just keep it at 0.25, so it's 3x plus 0.75. Okay, so we just have one equation, 4x plus 3x plus 0.75 equals $9.78. If I'm only using x, also only x, there's only going to be one equation in the problem. So I put my x's together, that's 7x. Then I minus 0.75 on both sides. This give me $9.03. I'm going to divide by 7. So $9.03 divided by 7 is $1.29. Now, there's your x, and that's for apples. So those cost $1.29 per pound. Now to find the other one, we just simply add the 25 cents because we know it's that much more. So $1.29 plus 0.25 gives me $1.54. Okay. Next one. There are a total of 700 tickets sold at a football game. Student tickets cost $3 each. Adult tickets are $5 each. The school made $3,078. How many student tickets and how many adult tickets are purchased? So I'm finding student tickets, but not their cost. I'm finding how many tickets, student tickets, and then adult tickets. Okay, so we got adults. We got the students, we got the money, 3 units. Okay, 3 units means we're going box. Again, you have no business trying to make a line out of 3 units. I know I did that 2 years ago. I should have been fired. Okay, so total, how many, and single. We have our adults, we have our students. Money, we have our money single, and we have our money total. Okay, cost for a single adult. Single adult is $5 each. Student tickets are $3 each. Okay. How many adults do we have? I have no idea. Adult tickets or student tickets. Neither one of those. Okay, so we talked about those 4 things. Talk about those 4 first. Now go fill this out. How much total dollars do you have? 3,078. Okay, then there's a matter of this 700 tickets. It ain't money, so gotta go on top because the top row is about how many. It has nothing to do with money. 700 tickets. Well, it's not adults. It ain't students. It's your total, of course. So I still don't know those 2 things, but since the unknown, the kind of the wild card number went right here, we need to call that X and that Y. So we got X and Y. So X and Y means we need 2 equations. Okay, got the first. X plus Y is 700. Now I take X times 5, that's 5X. Y times 3 is 3Y. Okay, it's systems time. We got x plus y equals 700. And then we have 5x plus 3y equals 3078. Okay, I'm going to use the elimination method. I have a bottom 5 as my coefficient in front of the x, so I will be multiplying the tops by 5. Here I have a 1, so I'll be multiplying these by 1. Then these both will be 5x. So 1x times 5 is 5x. 1y times 5 is 5y. Probably better go to my calculator and find what 700 times 5 is, and that's 3,500. Bottom 5x plus 3y equals 3078. Okay, we can either subtract them or multiply by -1. I'm going to multiply by -1. I always like to just add the equations together, but some of you might just prefer to subtract them instead of doing this -1 crap. 5 plus -3 is 2y. Then I add 3,500 plus -3078, that is 422. Then we'll be dividing by 2, and y is 211. Okay, y is students, so the student tickets is 211. Okay, now, I don't feel I'm doing a very good job explaining how to get this. I'm going to be a little more thorough. This is x plus y equals 700, because there were 1's in front, but originally it was x plus y equals 700. Get the y out and put 211. Okay, you don't have to multiply. X plus 211 is like 1x, so minus 211. Minus 211. 700 minus 211 is 489. Okay, boom. Last problem. 2 schools buy helmets and uniforms from a store. The school buys 5 helmets and 7 uniforms for $250. The other school is going to buy 7 helmets and 10 uniforms for $354. Find the cost of a single helmet and the cost of a single uniform. So I find cost of single helmet, cost of single uniform. Okay, so I got to find those two things. So we have the helmets, the uniforms, and then the money itself. So again, 3 units means I'm going chart. Total in the corners. Helmets, uniforms. How many? Single, and then the third unit's dollars, so money for a single, money for total. Okay, so let's talk about these first 4. The money for a single helmet, I have no clue. I mean, there's a money amount, but that ain't for a single helmet, and neither is that. So uniforms, we don't know that either. How many helmets? We got 5 and 7. Uniforms, 7 and 10. Okay. Okay, so my total money amounts, I've got 250 and 354. After you figure out these 4, let's get some totals down here. Okay, I have to use both x and y, okay? If I don't know anything about these, okay, with this row, nothing, okay? I don't even know that, so I need to use x. And by the way, this wouldn't be any dollars for single total. A lot of times this box is irrelevant, okay? I haven't yet put one in there, you notice what I'm saying. So I take 5 times x, 5x, 7x, 7y, and 10y. Okay, again, that's going to be 2 equations, so it'd be smart to set that up. So we got 5 times x plus 7 times y equals 250. The bottom we got 7 times x plus 10 times y equals 354. Okay, I have a 7 here. We'll multiply these by 7. And I got because of that, okay, 7, 7, 7, 7. Now 5, 5, 5, 5. You got to multiply them all, though. Let's going to be 35x plus 49y. 7 times 250 is going to be 1750. Bottom 35x plus 50y. And 354 times 5 is going to be 1770. Okay, add, multiply by -1. Okay. All these will go negative, out. So I take 49 plus -50, that's -1y. 1750 plus -1770, -20. Y is 20, okay? So the y is uniforms, that's 20. Okay, now I'm going to take equation number 1. I'm just going to copy that down. Okay. And then we're going to put 20 in for the y. Okay. And I need to find that product because there was a 7 in front of it. So I got 5x. 7 times 20 is 140. So 5 times x equals 110. Divide by 5. Okay, 110 divided by 5 is 22. Cost for a single helmet's $22. Okay. And my last one. One car has already traveled 300 miles and is traveling at an average speed of 40 miles per hour. A second car has already traveled 100 miles and is traveling at a speed of 50 miles per hour. After how many hours have they traveled the same number of miles? This is kind of weird. Sorry about this. Hours. So we got hours and we've got miles. So that's x, that's y. Again, 2 units. Back to 2. Per the miles per hour rate. And this is not going to be a direct variation. 40 and 50. 2 lines. So my m's are 40 and 50 respectively. Now, some of you are like, well, without any hours, you can't travel any miles. I know normally you can't, except if it tells you that you did. 300. 100. So, it told me, okay? Now, on this other problem, it didn't tell us that, so I just assumed we didn't, okay? So, it's a regular equation, and what we're going to do is we're going to take 300 plus 40x equals 100 plus 50x. Get your x's to one side. I'll minus the 40. I kind of like getting rid of the smaller one. Just avoids negatives. So that's 10x plus 100 equals 300 minus 100 minus 100, and 200 equals 10x. Divide by 10, divide by 10, and 20 equals x. 20 hours, that's a whole lot of driving, okay? Alrighty.